Congratulations on securing the job. Based on the details provided, the role appears to involve working with fuel and electrical systems, and these are complex topics. Let's delve into some fundamental concepts related to these systems to provide a foundational understanding for someone entering this field. Firstly, let's consider electrical systems. Electrical systems are the backbone of modern infrastructure, powering everything from lighting and appliances to complex machinery and control systems. A fundamental understanding of electrical principles is essential for anyone working with these systems. One must be familiar with Ohm's law, which states that voltage equals current times resistance. This is expressed mathematically as volts equals amps times ohms. This law is critical for understanding the relationship between these three fundamental electrical quantities. Voltage is the electrical potential difference between 2 points, analogous to water pressure in a pipe. Amperage is the rate of flow of electrical charge, analogous to the volume of water flowing through the pipe. Resistance is the opposition to the flow of current, analogous to the narrowing of the pipe. Secondly, consider power calculations. Power, measured in watts, is the rate at which electrical energy is consumed or produced. It is calculated by multiplying voltage and amperage. Therefore, watts equals volts times amps. Understanding power calculations is crucial for determining the appropriate size of circuit breakers, conductors, and other electrical components. Thirdly, one must understand alternating current, or AC, versus direct current, or DC. AC is the type of electrical current typically supplied by power grids. Its voltage and current vary sinusoidally with time. DC is a type of electrical current that flows in one direction only, such as that supplied by a battery. Many electronic devices use DC power and require AC to DC converters, such as power adapters, to operate from AC power sources. Fourthly, one should be familiar with grounding and bonding. Grounding provides a low impedance path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock hazards. Bonding connects all metallic parts of an electrical system to the grounding system, ensuring that they are at the same electrical potential. This minimizes the risk of electric shock if a fault occurs. Fifthly, consider National Electrical Code, or NEC, compliance. The NEC is a widely adopted standard for the safe installation of electrical wiring and equipment. It provides detailed requirements for conductor sizing, overcurrent protection, grounding, and other aspects of electrical installations. Compliance with the NEC is essential for ensuring the safety and reliability of electrical systems. For example, NEC Table 310.15 provides guidance on the allowable ampacity of conductors based on their size, insulation type, and ambient temperature. Other tables provide guidance on conduit fill, box fill, and other installation requirements. Sixthly, think about overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. They interrupt the flow of current when it exceeds a predetermined level, preventing damage to equipment and reducing the risk of fire. Selecting the appropriate size of overcurrent protection device is crucial for ensuring both safety and proper operation of the electrical system. Seventhly, keep electrical safety in mind. Working with electrical systems can be dangerous if proper safety precautions are not followed. Always de-energize circuits before working on them. Use appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses, and follow lockout/tagout procedures to prevent accidental energization. It's critical to verify that a circuit is de-energized using a reliable voltage tested before touching any conductors. Eighthly, let's move on to fuel systems. Fuel systems are responsible for storing, delivering, and controlling the flow of fuel to an engine or other combustion device. Understanding the principles of fuel system operation is critical for ensuring efficient and reliable performance. There are various types of fuel systems, including gasoline, diesel, and natural gas systems. Each type has its own unique characteristics and requirements. Ninthly, consider fuel storage. Fuel storage tanks must be designed and installed to prevent leaks and spills. They must also be properly vented to prevent pressure buildup and equipped with overfill protection to prevent spills during refueling. Regulations often dictate the design, construction, and operation of fuel storage facilities to minimize environmental impact and ensure public safety. 10thly, think about fuel delivery. Fuel delivery systems typically consist of fuel pumps, fuel lines, fuel filters, and fuel injectors or carburetors. Fuel pumps are used to transfer fuel from the storage tank to the engine. Fuel lines carry the fuel to the engine. Fuel filters remove contaminants from the fuel to prevent clogging of the fuel injectors or carburetor. Fuel injectors or carburetors meter the fuel into the engine's combustion chambers. 11thly, consider fuel injection. Fuel injection systems are used in modern engines to precisely control the amount of fuel delivered to each cylinder. They offer improved fuel economy, reduced emissions, and enhanced performance compared to carburetors. Fuel injectors are electronically controlled valves that spray fuel into the intake manifold or directly into the combustion chamber. 12thly, think about carburetors. Carburetors are older technology used to meter fuel into the engine. They rely on engine vacuum to draw fuel from the fuel bowl and mix it with air. Carburetors are less precise than fuel injection systems and typically result in higher emissions and lower fuel economy. 13thly, remember fuel system maintenance. Regular maintenance of fuel systems is essential for ensuring reliable operation. This includes replacing fuel filters, inspecting fuel lines for leaks, and cleaning or replacing fuel injectors or carburetors. Proper maintenance can prevent costly repairs and extend the life of the fuel system. 14thly, consider fuel safety. Fuels are flammable and can be explosive under certain conditions. Always follow proper safety precautions when handling fuels, such as avoiding open flames, sparks, and other ignition sources. Work in a well-ventilated area to prevent the accumulation of flammable vapors. Store fuels in approved containers and follow all applicable regulations. 15thly, consider fuel types. Different engines require different types of fuel. Using the wrong type of fuel can damage the engine. Gasoline engines require gasoline, while diesel engines require diesel fuel. Some engines can run on alternative fuels, such as ethanol or biodiesel. Always consult the engine manufacturer's recommendations to determine the appropriate type of fuel to use. 16thly, regarding fuel system controls, electronic control units, or ECUs, are often used to manage fuel delivery and other engine functions. ECU receive input from various sensors, such as oxygen sensors, throttle position sensors, and mass airflow sensors. Based on this input, the ECU adjusts the fuel injection timing, duration, and other parameters to optimize engine performance and minimize emissions. 17thly, fuel system diagnostics are essential. Diagnosing fuel system problems requires specialized tools and knowledge. Fuel pressure gauges, scan tools, and multimeters can be used to troubleshoot fuel system issues. A systematic approach to diagnostics is essential for identifying the root cause of the problem and implementing the appropriate repair. 18thly, think about ventilation. Proper ventilation is essential when working with fuel systems to prevent the accumulation of flammable vapors. Ensure that the work area is well ventilated and that any potential ignition sources are eliminated. Use fans to circulate air and prevent the buildup of vapors in confined spaces. 19thly, consider personal protective equipment, or PPE. Always wear appropriate personal protective equipment when working with fuel systems, including safety glasses, gloves, and a respirator if necessary. Fuels can be harmful if inhaled or absorbed through the skin. PPE can help to minimize exposure and prevent injury. 20thly, consider spill containment. Have spill containment materials readily available when working with fuel systems to prevent spills from spreading and contaminating the environment. Absorbent materials, such as spill pads and booms, can be used to contain and clean up spills. Dispose of contaminated materials properly in accordance with applicable regulations. 21stly, think about electrical components in fuel systems. Fuel systems often incorporate electrical components, such as fuel pumps, fuel injectors, and sensors. Understanding the interaction between the electrical and mechanical aspects of fuel systems is crucial for troubleshooting and repair. Use wiring diagrams and test equipment to diagnose electrical problems in fuel systems. 22ndly, let's talk about codes and standards. Fuel systems are subject to various codes and standards, such as those established by the National Fire Protection Association, or NFPA, and the Environmental Protection Agency, or EPA. Compliance with these codes and standards is essential for ensuring the safe and environmentally responsible operation of fuel systems. 23rdly, consider system design and how it relates to your job. Consider the specific types of fuel and electrical systems you'll be working with. Are they gasoline or diesel fuel systems? What are the voltage levels in the electrical systems, such as 120 volts, 240 volts, 277 volts, or 480 volts? The more specific you can be with the type of systems, the better you will be able to apply the above. 24thly, think about continuous learning. Technology in both fuel and electrical systems is constantly evolving. Staying up to date with the latest advancements through training courses, industry publications, and professional development is crucial for maintaining your skills and knowledge. This information provides a broad overview of fuel and electrical systems. The specific knowledge and skills required for your job will depend on the specific types of systems you'll be working with. Good luck in the new position.